Hello, my name is Lee Presser. This is my show. I speak frequently to very interesting people. Some of these conversations are so exciting, so intellectually stimulating, I thought others might like to listen in. This is the reason we started recording Conversation with Lee Presser.
Welcome to Conversation with Lee Presser. Solar energy and battery technology are going to be discussed today. For non-engineers, which is most of us, there's a belief that alternate energy technologies are designed and ready to be deployed. Some believe the conversion to alternate energy systems is being blocked for economic reasons. Our guest today is an engineer. Dr. Andy Lozowski runs the Power Electronics Laboratory for the Department of Electrical and Computer Engineering at Southern Illinois University, Edwardsville. His research area involves design of energy conversion devices. He commutes to school on an electric bike using energy captured with roof-mounted solar panels. In the next 30 minutes, I'll be asking several important questions. Can electric consumers in the United States stop using fossil fuels, coal, natural gas, petroleum, in the near future? If so, what might the infrastructure look like? Will electric consumers of the future be able to get off the grid? Dr. Andy Lozowski, welcome to Conversation.
Nice to be here.
I guess I really want to start with the very first thing that I mentioned, and that is, are alternate energy systems designed and ready to go? And by ready to go, I mean as a substitute for all the electricity that we are using right now.
Mm-hmm. If they are ready, technology exists, but it's not going to start today and probably not within a decade. There is some more work to do. Basically, technology originated in the 60s and 70s and has been existing since then. However, we were kind of slow in deploying it, and there is not much interest among the consumers just because it's very expensive. So that's the story there.
It is more expensive than just what we're using today.
Practically, the issue is the initial investment, because the solar panels, the inverters, and all the technology has to be bought first. And then once you start producing free electricity, you're making money. However, in order to recover that cost, it will take you probably 20 to 30 years.
When you say you mean the homeowner,
a homeowner
who has... I'm going to put up a picture here on the screen right now. This is from the front page of the Post-Dispatch. We're going to talk about the article in a little bit, but I just want people to see this is what a solar panel looks like. Now, this solar panel actually converts sunlight into electricity, right? As opposed to the kind of panels that existed back in the 70s and the 80s, which actually captured heat and heated water, right? That was the original designs, was that you would heat water, and that's what would keep your house warm.
That's correct. There are two ways to go about this, and those particular panels, they create the DC electric current, and then you have to take that current, convert it to an AC voltage that you would see in your household.
Just like you plug into.
Yes. Most appliances, most of the equipment that we have in our homes is designed for the household voltage, the AC. So once we have the DC current from the panel, we have to add some extra processing. That's adding the cost too. You have to have an inverter. And once you're at that, you have to do it properly, because the utilities don't like low-quality inverters, so you have to buy one that gives you the pure sine wave. And
now you're using some technical terms here, so let's just, for people who aren't familiar with what an inverter is, just briefly explain what is it and what does it do?
Okay, inverter takes in a voltage like you would have in a car. You have a car battery that has 12 volts.
What's called DC,
it's the DC.
Direct current.
Yes, and then it takes that and it converts it into alternating sinusoidal power that's coming out of a generator you would have in a power plant.
Like AC.
Like the AC.
Okay.
And it steps up the voltage as well, so it's 120, plus it adds a little bit of regulation. It has to be such that it's in agreement to an existing, because you practically plug it into the wall, backfeeding the existing grid. So what you have to do is make sure that you're not competing, you're not loading it or you're not causing sparks. So you have to do it the right way.
So when you plug in your vacuum cleaner or any other, the microwave, into this converted DC to AC, you want it to be pure energy rather than having a lot of discrepancies in the signal.
True. You don't want to find yourself in a place where you plug in the inverter and all of a sudden your radio is noisy, or you cause some kind of intermittent blackout in your house, and you don't have problems that way. So those inverters are available. You can buy them. They're a little bit costly, and that's the major problem with this, that in addition to the cost of the panels themselves, it costs extra money to install them, to have those inverters, and also, if you are thinking about producing electricity, the utilities are not giving you dollar to dollar. If you have excess power, when you sell it back, you get a little bit less than what you pay if you use it.
Yeah, now that's what you just said there at the end is another issue that people may or may not be aware of, that after the 1973 energy crisis, there were some laws that were passed by the United States Congress that said that people who were capable of generating their own electricity in the way that you just described, they could actually send it back through their electric meter and sort of unwind the meter. Isn't that right, or am I mistaken about that? And they would do that in such a way that that the cost of electricity, they'd be taking off. And if you generated enough electricity, the electric company might be paying you for the energy that you were creating. But you're saying that they're not going to pay you as much as they're charging you for the same amount of energy.
That's true in most cases. Plus, that the cost of electricity may be variable during the day, during the peak hours and off-peak hours. It's another story there. And in addition to this, the electric meters, they don't wind like they used to. They're all electric, so they're now fully equipped to actually do this. In the past, it wouldn't be necessarily the case that it would actually go backwards. But presently, most of the installations are capable of doing that. And of course, you would have to have a pretty substantial installation in your house to be able to do that. Most of the cases where you have just a few panels on the roof, you're just subtracting from the use. You're not really generating power. Plus, that's mainly during the day. So there is another story that comes with it. How do you store electric energy? It's available during the day. For the night, you still have to use the one coming from the grid.
Or batteries.
Or batteries.
Right.
That's another idea that there are countries like Australia that invested a lot into battery storage, so that you can be off the grid or not use electricity from the grid at all. You still have it hooked up, but you're just not using it. Or
when we say the grid, by the way, folks, we're actually talking about what you're getting from Ameren or Illinois Power. This is the energy that we're talking about. When you're on the grid, you're getting it from them. When you're off the grid, you're creating your own energy, right?
That's right. And there are two ways inverters are built, or those solar installations are built. Some of them, they're so-called grid tie inverters. You have to have an existing grid to be able to produce power. And if the grid shuts down for whatever reason, if the power is out, your inverter is not allowed to produce electricity if you're a grid tie inverter. There's the off-grid installation, in which you don't need an existing grid. Your inverter produces the power, and it pretends to be your own local grid. And it's like an island. And you have to have a kill switch or something to be able to disconnect from the grid if you want to be the grid tie. And if you want to switch over to being off-grid, you have to completely disconnect and shut down. So this is another policy issue that would be nice to resolve, because presently this is kind of limiting, because naturally people would think, well, if the power is out, I'll just use my inverters because I have electricity. Well, no, you can't. If the grid is down, you have to shut down your production as well.
Now that's confusing as to why you can't use your solar panels to create your own electricity for your own house?
Well, if you disconnect from the grid, then you can, yes.
Okay.
But it has to be automatic, and it has to happen within a second.
Okay. And there probably are reasons why the electric company is requiring that.
Main reason is probably the safety of the utility workers. You know, you don't want to find.
I see. So if they're out, if the power is off in the wires, or at least they think it is, and you're generating electricity into the wires, then they're liable to touch it and perhaps get electrocuted.
That's right.
Okay. Now let's go back and start talking about some more basic things. Solar panel, like this, what I was showing here. What is a solar panel, and what is it actually doing? It, you know, the sun strikes it. What happens when the sun is striking it?
Okay. So the way the solar panels are made is, in short, a process like this. You produce a big bulk blob of silicon, basically, and you slice it into those tiny wafers, very, very thin wafers, and they're about this big around. And then you have a choice. You can make maybe 4, maybe 5 Pentium processors out of one wafer like this and sell them for $200 each, or you can make just one solar cell and sell it for $20. So, and the amount of silicon that is being produced in the world is just not enough even to sustain the production. You'd have to deploy more and more facilities to build those. However, once we have those slices, we make this into one giant diode. Diode is a semiconductor device that conducts electricity in one direction. If you completely encapsulate that, you have a diode. But if you expose this to the light, the light, the quantum of energy hitting that is going to generate a positive and negative charge on both sides of that diode that can recombine outside of it, creating this electric current. So if you have enough of those quanta coming in, then you have continuous current flowing. And basically that's your about 3 watts of power on one cell. And then you have many of those cells stacked together in a string, and that is going to give you a 100 or 200 watt panel that generates the DC current. It's a pretty simple device.
So the efficiency of these diodes that you were talking about, that's really a big deal then, because the more efficient, the more you might get more than 3 watts out of it. You might get 4 or 5 watts, and if it's less efficient, maybe only 2. Am I reading that correctly?
Yeah,
and has there been an improvement in these efficiencies, say from when we started talking about this in the 70s to where we are here in the early part of the 21st century?
There has been. The efficiency more than doubled since then. So you would have, depending on technology, efficiency in, let's say, 10% or something like this in the 70s. Now you're more than 20% efficient with this. Efficiency meaning that the amount of power that's available in the sunlight versus how much actually is coming out of the panel. And there is a theoretical limit. You cannot go over 40-something%. So there is still some improvement that can be
Which we're at
made.
20, and you're saying that the limit is 4. So there's still more room.
There is more room
to
for
make
improvement.
things more efficient.
However, there is also a limit in our patience, or how much do we really want to invest to improve efficiency? Why don't we just build more of them and have bigger surface area? That's easier to do.
Now here's the real question. I mean, I've heard you talk about, okay, you've got to do all these things, and you're creating these little diodes, and they're $20, at least right now, they're about $20 each. And yes, you can make a huge panel or multiple panels with that times 20. But the question really is, for your house, is it efficient to do it that way, or is it more efficient to let a coal or gas generator at some remote location generate that electricity and send you the electricity through their wires?
Well, efficiency-wise, you have energy for free once you have a panel. So it's just the question of how long would you have to wait for your investment to return the money. Once you are using electricity from a plant, you will end up paying money, as you...
Yeah, you're renting.
Yeah, you're renting that.
Versus buying.
Talking about renting, there are some ideas there that there would be a solar company that rents your roof and puts up the panels on your roof. They pay for that. You just get some portion of what they produce. There is a financial idea that could be developed to actually help the consumers or the household owners to actually have electricity produced on their roofs. That possibly is going to happen more and more because there is so many roofs available, and in a city there is no room to put the solar panels only on the roofs.
When you and I were talking on the phone when we were first talking about this show, you said something about some subdivisions might get together and have all these roofs covered and be able to share energy back and forth within houses within a subdivision. Is that?
Yes.
Explain a little bit about what you were talking about.
That's the idea of a microgrid. Let's say you have two houses, right? And one house has an air conditioner in it. And to start up the air conditioner takes a tremendous amount of power. And no solar roof, individual roof, no matter how big it's going to be enough to start up the air conditioner. So you will have to use an external power. Now, if you have 10 houses, not every air conditioner is going to start at the same time. You can actually make them, offset them, so that they never start up at the same time. Now, 10 roofs together will create enough power to start just one air conditioner. So you start that one, and then the power drops to just maintain its operation. Then another one can start, and another one. So within 10 or 20 houses, your net is going to be pretty continuous consumption of the power. So if those houses together would generate their own power, they would be able to completely have no current coming in from the grid. They could just redistribute their production and maybe have just one point where they connect to the grid for the night, or if something happens that they don't lose power. So the microgrid would be the local connection of houses, and then one point where they connect to the normal grid. So this is the concept of the microgrid. Right now we don't have any equipment or even research is not there yet to have this ready to deploy, but that seems to be an idea that is present in the publications right now, and that's where people are looking at, to have those localized microgrids and then individual points to connect to the grid, rather than having every house directly connected to the grid as today and trying to add to that power with their local production.
Now you make an interesting point when you say this, that no one house with solar panels on the roof is going to be able to generate enough electricity to run an air conditioner. Now that's because, I mean, to cut to the chase, air conditioners, home air conditioners, require huge amounts of power in order to operate, especially at that moment when the fan is first kicking on.
That's right.
And that brings, the question of, in a world that is power hungry, I mean, when you look at an automobile factory, or you look at some other kinds of heavy industrial users of electricity, is it possible that solar energy could substitute for the kind of generating capacity right now that we have with centralized generators burning or doing something in order to create huge numbers of megawatts of power?
Mm-hmm. Well, today probably not. However, we have a lot of surface area at our disposal. All the interstates, the highways, the area that are not being used for agriculture. All of those areas are just there, sitting, doing nothing. That could be places where we produce electricity. And after all, except for the nuclear power, most of the energy came from the sun anyways. Mm-hmm. Even the wind energy is really, a secondary thing. The radiation from the sun is the natural place where it starts. So the power is there. Is just how do we make it feasible in terms of infrastructure and location and then transportation of energy? Mm-hmm. And we don't have to do it all in the solar power. The point would be to just get started, because mm-hmm. there is very little that we do in this area. So if we get started, that would help. And obviously there are places like Alaska where things would make sense, because you have too much clouds, or the sun wouldn't be available.
The sun comes in at a steep angle also.
Yeah. So, but the U.S. has plenty of areas where the solar exposure is tremendous. So we should take advantage of that.
Okay. Now we talked before about storage, and then I said battery. And there has been, I mean, since the 70s, there's been talk about battery cars or batteries that are going to be able to store huge amounts of electricity. But most people know batteries as two things, either the dry cells like you put into electronic devices, or the battery in the car. Those are the two main batteries that we know. What other kind of batteries are either in existence now or on the drawing boards that could capture this solar energy in one's basement, so that then at night you could still have your air conditioner and your lights and maybe use your microwave?
Yes, the main argument against batteries usually is their life. Lead acid battery, you can maintain it to last for about 10 years, but then it's eventually going to stop working and you have to buy a new one. And that's, again, another expense. Plus, there's environmental issues involved with that. Yes.
There's disposal issues.
Yes, you could recycle some of that content. However, there is this one technology that's the very first technology. I think Edison built the first battery, which was nickel-iron battery. And the one that he made is still in existence, and it still works. So, you know, easily you can get 50 years of life out of that. You know, the disadvantage of those batteries is that they're very big and heavy, but once you have it in the basement, you don't really care how big it is. You know, you're mainly interested that you don't have to maintain this at all, and it's not going to die, you know, within the lifetime of the house. So there are batteries that could be created for that particular purpose. So this is one thing. And another, batteries are not the only choice in here. There is some research in the area of giant flywheels that actually can store more energy than the battery within a volume of space. So if you have the area in the basement, you have the supersonic flywheels rotating at tremendous speeds, and they can actually store more energy than the batteries. They're suspended in the vacuum, so there is no friction, and the technology can be developed. You know, that's not available, but that's something that we could do. And the storage in the basement in the batteries is one idea. Another would be to actually use the batteries in a car. If you have the electric car, I'm talking about the batteries for electric cars, not the appliances batteries. They have usually nickel metal hydride or lithium-ion batteries, and they're going to have to be maintained no matter what. If you have a car, you will want to change the battery when it goes down, so it is going to be there anyways. You could use that to charge that from your solar installation. You could even run the house on the car battery at night, because they have a lot of potential in that area. Plus, the charge in the battery is like your currency. So you could charge the battery during the day, during the off-peak hours, and use it during the peak hours to kind of make it cheaper for yourself to use electricity.
From what I'm hearing from you is that there are many ideas, but like in the early days of electricity, we as a society, we as a world haven't really settled on any technology yet that we're going to go forward with and make use of. So am I?
That's
I mean,
true.
one of the most interesting things I've heard you say so far was this flywheel. I'm going like, well, gosh, there's an interesting technology that most people probably haven't even heard of this technology before. But that's what's good about engineers. They come up with new ideas. So in the last 5 minutes that we have here, what other areas would you like people to know about these new technologies and emerging technologies?
Well, probably the most important thing is that the silicon industry or the semiconductor industry is growing pretty fast, and there are new devices that are being even today researched that were not even available 10 years ago. So those inverters, very efficient inverters, were not possible 10 years ago because we didn't have the switching devices that we have now. And we now are looking into silicon carbide rather than silicon devices. This is the new technology that can work an order of magnitude faster with the same efficiency. That basically means that your inverter that would be good for 50 kilowatts of power is going to be about 1/10 of the size of what it would be today. And the devices are being researched and produced as we speak, and what we need to do, especially in the education, we need to follow up on that. We need to basically prepare the students to be able to read about this, because we don't have books about this yet. So, but at least we have to make them hungry for that knowledge, so they look into the future. As they graduate, they will have to learn more on their own to be able to do their work and catch up, basically.
Mm-hmm. And do you find that a lot of young, and I'm talking about younger than coming to SIU, that those mm-hmm. people are really up to speed on stuff and are reading about it, or they come there and they're like, they have no clue about the things you're talking about?
That depends on the individual. There are always a few very motivated students that read on their own. They tinker, they have a box of parts, and they do things on their own beyond the classroom assignments. And these are the people that are going to be the leaders of this motion in the future. You still have to have a lot of people that are going to do maintenance. They're going to understand, if they're salesmen or people like that, what the issues are. And you know, it's always old generation versus young generation about who's smarter, and you know, we just have to find the very bright individuals to push them in that direction.
I mean, let's face it, it was a bunch of fairly young people in their late teens, early 20s that invented what we now call the whole personal computer industry. Mm-hmm. You know, it was just to meet their own needs. They were just looking for something to meet, you know, I have an idea, and they just go ahead and did it, and next thing you know, the world has changed. Hopefully there's those same kind of people who are going to accidentally maybe bump into the solution to this energy situation.
That's true. That's typically happening when you have the people who are already comfortable with the existing technology, not even wanting to look anywhere else because they're just too comfortable. Same happened with switch from analog to digital technology, and maybe now it's going to be time to move over to the local production of energy rather than the centralized monumental giant power plants distributing energy in every direction. Mm-hmm. This takes you have to be comfortable with the new things, and not everybody is willing to change or learn. You know, once you get to a certain age, you prefer what you know. Mm-hmm.
Well, unfortunately, I wish that we had much more time, because there's so many other questions that I had. There was this paper. I guess in the last few seconds, I wanted to just say that Americans just don't seem to be doing a very good job of producing these solar panels, because the Chinese right now seem to be able to underbid Americans. Is that, in just a few words, is that correct? Well, and this industry is developing there, and we're really out of time. So, mm-hmm. But is that essentially correct? Their governments are investing in this, and ours are not.
Well, their governments are investing in this, and I would say it's a fair game. I mean, you need to compete, then let's compete.
Yes. I said we're out of time. I've been speaking with Dr. Andy Lozowski of Southern Illinois University School of Engineering. For more information, go there. The rest of you, we'll see you next week. Thanks.